Running on the rail cars, right? Okay, so we've got, okay, so let's see, 60 kilogram Brennan. Wouldn't that be fun? This is 560 and 780. This is 560 plus 60, right? And everything is at rest, right? Everything's at rest. So this is 0, this is 0, right? Then in the next picture, he runs, and in the next frame, I'm going to show him between these carts, right? Okay. So this is 560, and this is moving at some velocity. He's going 5.2 meters per second, and he's 60 kilograms, and here's that other cart, right? And this cart's not moving because he hasn't touched it yet, right? He's run off of this cart. This will be going backwards. He's going forward, right? Okay. And then I think we've got the picture we need, right? So we want to just know what's the velocity of car A when he's in midair. This is car A. That's B, right? On car A. Okay, oops, sorry, that's B. Okay, so here we go. So the total momentum before is 0, and then afterwards it's 560 times V plus 60 kilograms times 5.2. Okay, so here we go. I'm going to take this on this other side. So I'm going to go negative 60 times 5.2 and then divide by 560. And I get that that velocity is 0. Negative ta-da. So we got, there we go, we're good. All right, so now let's go do the next one. What's the velocity of car B when he leaves it? Well, that's tricky, right? Okay, so we've got a velocity. We got this guy and this guy, right? So everything's sitting still, right? Then we've got him in midair, coming apart, right? Okay, then we've got the cart, right? Then we've got, in the final picture, it's, he's jumping off the cart, right? And so here we know his velocity is 5.2, right? And he's 60 kilograms. Okay, and we know this velocity is 0, and that's 780 kilograms. And then this is all, by the way, 560, right? And then in this picture, we know that's 780, and he's going 3.4. Okay, to the right. So he slows down while he's on this cart, right? Okay, so by the way, what I can do in this picture is I can ignore that first cart. I'm going to make, this is my system. My system is these two carts, the cart in Brennan, the second cart in Brennan. So I know the momentum of everything in the circle here and the momentum of everything there, and I'm going to ignore this cart. I can do that because he doesn't touch that cart from here to here, right? So I can go 60 times 5.2 plus 0 equals 780 V plus 60 times 3.4. Now, by the way, you figured out the velocity of this cart. So if you want to put it in there in this picture and put it in there, it'll just be the same thing on both sides of the equal sign, so it won't matter. But go ahead and do that. Remember, it's going negative 0.5571428.571. You could do that, but understand that in this picture it would be here, in this picture it would be here, the term would be there, and it would be the same, and it would just eliminate itself. So it doesn't matter. This is mathematically legitimate. Okay, so you can draw a picture, and then you can just look at any part of the picture you want to, as long as it doesn't interact with things that aren't, as long as it's an isolated system, right? Okay, so here we go. So I'm going to go 60 times 5.2, and then I'm going to subtract 60 times 3.4, and then I'm going to divide by 780. Whoops, I'm getting tired. And I get that the velocity is actually positive 0.138 0.46 meters per second. Now, why is it that? Well, it's that because he slows down on the car. He's got more momentum here. He's got less momentum there. So the car is carrying some of his momentum. Right? The momentum of this circle has to be conserved. Okay, let's answer the last question. What would have been the velocity of car B had he remained there and not jumped off? Okay, so let's draw our picture. Here he is to begin with. He's on the carts and they're not moving. And he doesn't have a head. Okay. And then we've got him in the midair, right? And we figured out how fast this cart's going to the side. But we know he's going 5.2 here. He's 60 kilograms. And this cart he hasn't landed on yet is 780. And then in this next picture, he's going to stay on that cart, right? So here it is. He's going to stay on the cart, right? So this is 780 plus 60, right? Going at some V, right? Again, I can do the circling thing. I can circle this part of this system and this part of this system. The same objects are in both circles. It doesn't touch this first cart. We don't touch it from here to here, right? It doesn't matter. Okay, so I'm going to go 60 times 5.2 plus 0. The cart's not moving before he lands on it, right? 780 plus 60 is 840 times V. That's a simple, it's like bullets sticking in block of wood. It's the same problem, right? So 60 times 5.2 divided by 840. And that velocity is 0.3714 meters per second. What would have been the velocity? Is that the last one? Oh no, oh my gosh. What would have been the velocity of car B had he jumped off the back of it to give himself a velocity of 0? Okay, so again, let's draw a picture of him before he jumps on that cart. He's going 5.2, right? And this cart's going 0, and then after this, he jumps on it, and then he jumps. So he's on, this is the second cart, right? He's on the cart. Apparently it's going 0.3714, what we figured out in the last problem, right? Okay, and then he jumps off that cart so that he has 0 velocity. So you'd have to jump off the back, right? So he's got 0 velocity. 60 kilograms going 0. This is 780 going V. Okay, we don't care about the middle picture. We just care about this picture. So I'm going to go 60 times 5.2 plus 0. He hasn't landed on this cart yet, right? Equals this picture here. So 60 times 0. He's not moving. Plus 780 times V. It would be very hard to do this, by the way, to jump off the back of a cart so that the cart's not moving, right? Okay, so here we go. So 60 times 5.2, I guess just divided by 780, right? Basically, he takes all his momentum away and gives all his momentum to this cart magically, right? So V is exactly 0.40. That's a 4. I chose not to put these, I love these problems, right? I chose not to put these on the assessment just because, I don't know, these are hard enough as it is. Anyway, happy hunting.